Hi, if you're joining me at the right, whatever. So, I think I have like 3 views overall, whatever. I'm not going to make millions. So you would subtract 1, divide by 24, which means 1/23rd. Then what would you do? Are you with me, youngsters? Subtract 1, you got 1. Divide by 24, so 1/24th. Then you would natural log 1/24th. Then you would divide by negative 0.75. So the time would be log of 1/24 divided by negative 0.75. So we have that. I got it. You just sit there and look pretty and all here. All right. Log of 1 divided by 24 divided by negative 0.75. 4.237. I didn't define the time unit, so you have to take that for whatever the time unit is. Okay? You with me?
Yeah.
Okay. I think that's it. You should be in pretty good shape here. These consist of some normal problems, but a lot of AP problems. So give it your best go, and we'll go over tomorrow. Let's go to next. Do we need to finish? Do we have notes? Do we need to finish those notes? Are those notes of any value?
Finished like B and C on the last one.
No, it's okay.
That's fine.
Let's actually look at them and see if we just did stuff like it, or I know you just say,
Well,
what the
like the
heck?
thing is that we just did a problem basically like that.
Is that okay?
So, I mean, we can do a problem like that.
Yeah. All right. So what we just did is kind of like what this is. You're right. How many on Thursday would be finding population at time? This would be finding time with population. So we pretty much did all that stuff. If you'd like to go through the notes and complete them, fine. But otherwise, let's move on. Okay? All right. Now, would you pick up that homework that you just got back? I started by looking for lots of little things, but then the lunch period got shorter and shorter, and so I started doing a quicker and quicker job. So some of you got really thorough work, and some of you not so much. I do want you to know whether you did this well or not. All right? So first of all, do you know our math? Reset 115, practice. You with me?
Yes.
Make some corrections here, if necessary. This one was pretty straightforward. You should have only had 2 integrals. When you decompose it, it should have been a 1/6 over x plus 3 and a 1. Is it negative 1/6 over x plus 3 and positive 1/6 over x minus 3? And so there's your answer, yeah? Okay, some of you I know have a mistake on number 2. Your decomposition should be 1/5 over x and 1/5 over 5 minus x. That's not where the mistake is. Many of you made a mistake in integrating 5 minus x. When you integrate 1/5, it's obviously 1/5 natural log of x. That is a negative, and a U-sub problem. You pick up a negative, see if you have a negative there. It better be there. It's supposed to be there. If you don't have it there, you integrated 5 minus x in the denominator wrong. Most people did this one well. It was negative 1 over x plus 4 plus 1 over x minus 1. Not a lot of gotchas there to that integration. So that should be log of x minus 1 minus log of x plus 4. Check? Hey, some of you have this guy wrong. Most of you did it correct. When you have 3 factors in the denominator, you must have 3 fractions. It has to have an a, a b, and a c. You cannot use x squared minus 4, because if you get x squared minus 4 with one big fraction, then what will you have to do as an integration technique? Then you'll have to trig sum, okay? You don't want to do partial fractions and trig sum unless your teacher makes you do it in a couple problems. you would prefer that you can do 3 linear factors. So you should be using 3 linear factors, not a square factor, all right? On 5, check your division first. Some of you have a division error. It should be 2x plus 5, or 2x plus x plus 5 over x minus 4, x plus 2. Check your division is your first step. Then check your partial fraction decomposition. When you decompose the remainder term, you should have 3 halves over x minus 4 and negative 1 half over x plus 2. Then check your integration, x squared plus 3 halves log of x minus 4 minus 1 half of log of x plus 2. Okay? Are we good? Moving on to 6. Yes? Okay. 6. Part of the thing I want to check is in the partial fractions, you should be integrating something like 1 half over 1 plus x and 1 half over 1 minus x, yeah? This is that same issue of a negative u in there. So check your integration. Did you have 1 half log of 1 plus x minus 1 half log of 1 minus x? Did you get a negative from that use? Okay. Now when you trig sub this, you should be using something like, what? X is sine u, or theta. Your integral you should get is just, when simplified, secant of u du. Yeah? And then when you integrate that, get log of secant plus cosecant. This is what you get, right? Now, this kind of problem is where I tell who's the math nerd, like I was. I would then say, well, these are supposed to match. 2 methods for the same problem. Do they? How do they coincide is the word for that mathematically. Do those coincide? Well, you have one of 2 ways to do it. You could, and you don't have to do this, but theoretically thinking, you could put this all together and make it look like that, or you could blow this up and make it look like that, which would be easier. Let's say we went here, just one time for sake of understanding. I could put that together into x plus 1 over root 1 minus x squared. Yeah? Do you agree? Okay. I could also factor that denominator into 1 plus x to the half and 1 minus x to the half. Now these guys combine into x plus 1 to the whole power over to the half. Isn't that x plus 1 to the half? Oh, oops, not those guys. Those guys combine. Not that one, sorry. And this is in the denominator. Now, isn't that the same as if I did subtraction of the 2? Should be absolute value on that. And then brought the exponents down. And that's what it is. Okay? Now, why 1 minus, yeah, that's fine. All right, you follow? All right. Look at 7. A lot of mistakes in 7. Not so much on the partial fractions. The partial fractions probably were okay. It was on the trig sub. On the trig sub, first of all, check you're completing the square. I had a handful of people make an error completing the square. You should get x minus 2 squared minus 1. If you don't have that, you made a mistake completing the square. Check that square. Okay, after that, your substitution should be x minus 2 equals secant of u or secant of theta. When you substitute in, clean up a ton, it should clean up to cosecant theta. And if it doesn't, you made a mistake somewhere in the cleanup. you integrate, it should be log of cosecant minus cotangent, and then I had a handful of people leave it there. You have to sub back. Your answer should be in terms of that. You cannot leave it there. All right. So then you'd sub back with the triangle. And it's the trig sub answer looked like that. It was a big mess. Okay? That's what the trig sub answer looked like without any combined. All right, and then the back side. Can I go? The back side, first check your division. That's not, did I change this? Yours just says 2x cubed in the numerator, right? Okay. 2x cubed. So because it's improper, you should have first divided, check your division. Did you get a division or a quotient of 2x plus 10 plus 48x minus 60 over x squared minus 5x plus 6? Do you agree with that? Okay. Then check that you decomposed it. When you decomposed, you still have 2x plus 10, but the decomposition of the remainder, I got 84 over x minus 3 minus 36 over x minus 2. Do you agree with that? No? Okay, because this is where I started getting tired and my eyes started getting buggy, so I wasn't feel confident. So I don't hear a lot of, yeah, that's what I got. What did you get for your x minus 3 numerator? 48? Any else? 48? 84?
Yeah, 84.
I got 84.
I got one up there.
Oh, why didn't you tell me, man? Starting out. No? Lily?
I got
You
one.
gave me a check
No?
mark, so I called.
Sydney? I just checked that you did it. With those
Oh,
checks.
Is that
then
20x?
never mind.
Amanda, what'd you get?
Okay.
Okay.
Did I say 2x plus 16?
That said 2x plus 10.
I got plus, oh no, I got that. 2x plus 10.
And you didn't get, so you agree with the quotient, but we don't agree with the partial fraction decomposition.
I agree with the partial fraction.
So you do 84 and 36.
You gave me a check mark, but like.
That doesn't mean
yeah.
anything. This is what,
Wait, what did you just?
so it feels like we have a lot of disagreement
Oh,
there.
You should probably just do it. You should probably just do it right now.
Okay,
Wait, what did you get on your division?
so let's
Got
go here.
38x minus 30.
38, not 48?
Because it's like, it's 15 minus 12, negative 12 plus 50. So it's, yeah.
Oh, I have the 40 10x squared minus 2x. Oh, that's a 12. So that should be 12x. So you have 38 here. Oh, yeah, I agree. 38x minus 60?
Yeah.
Okay, so if you proceed on with that then, so my first quotient is fine, but obviously that'll change the decomposition. So what's your x minus 3 numerator? 84? 54? What did you get, Cindy? You had 38, you said.
Really don't.
Jesus.
I have 48.
So do we have 38x minus 60? Do we agree with that? We don't agree with 38x minus 60.
Oh, it's totally 38x.
Okay. All right, so now if we decompose that, let's settle this once for all. 38x minus 60 equals a times x minus 2 plus b times x minus 3. If we let x equal 2, then 76 minus 60 is 16 equals b times 5. B times negative 1. So b is negative 16.
Why does everybody tell me I'm wrong?
No, you should have more confidence in yourself. X equals 3 is 90 plus 24, 114 minus 60. So I'm feeling 54 equals
Hold on a second.
a times 4.
How did that happen? Wait, what did you say?
38 times 3 is 90 plus 44, so 114.
Oh, yeah, that was like that.
All right, so it feels like it should be 2x plus 10 plus 54 log of x minus 3 plus 16
X squared plus 10x.
x squared plus, oh, I didn't integrate this, x squared plus 10x, yes. X squared plus 10x plus 54 log of x minus 3 minus 16 log x minus 2 plus. Darn it, should have gone with last year's key, I was a little less tired. Yeah, that's, nope, still not like that, I missed it 2 years in a row.
Were you trying to do this?
I don't know, for me, 8 o'clock is real late, so if it was 8 p.m., I would have died. All right. Okay, questions on set 115.
Number 2.
2. 20? 20, okay.
Does anybody say 3?
Nope, not yet.
After you about
3.
3. Don't worry.
What else is there 3?
Oh,
24? 3 and 24.
just like a quick question.
Really?
We use our calculator for 5 and 8.
For 5, 5, it's not necessary. 8, yes.
5 is not necessary.
No, you'll be able to use an identity, it'll speed up so much, it'll just be integrating 6.
So,
5, no, 6, yes. Or 5, no, 8, yes, sorry. All right, 2. Is 2 still a question?
yes.
All right. 2, you're estimating the cube root of 8 using differentials. All right. It's not that? Oh yeah, cube root of 8 would be great. That's stupid.
What's the opportunity?
I would guess somewhere around 2.
Yeah. Okay. Did you just focus on the differential first, or did you do this kind of approach? All right. So you can find the differential first and then play with it, or you can do it all at once. It doesn't matter. So if you did the differential first, and in my mind, I would start with identifying what's the good point and what's the function. The function is the cube root function, and the good point is when 8 goes in for x, 2 comes out for y, right? So have clear in your head what the x and the y are and what the function is. It's a lot like the choice to find a tangent line. All right? So dy is f prime at x initial times some change in x. The derivative of x to the 1/3 is 1/3 x to the negative 2/3. And we're going to do that at x equal 9 or x equal 8. And x equal 8. And what's dx? Positive. Because we're going from 8 to 9, not 9 to 8. Or we could say we expect it to increase. Going from 8 to 9 is going to get bigger. All right. So this then is 1 over 3 times the cube root of 8 quantity squared. And so I feel like 1/12. Jordan, this doesn't look like what we got when I was helping you yesterday. I might have helped you badly. Sorry. Anywho, 1/12, right? Now, the new y, which is the question, the cube root of 9 is approximately equal to, well, y0. What's the starting point? The cube root of 8, which is 2, and then we're saying it should change by about 1/12 and increase. And so I would expect it to be 212. That's, yeah, the change from the good one. All right, are we good with 2?
Yeah.
20. Question on 20. Yes? Okay.
Oh, yeah, 20.
Righty, this is pretty gross. I am with you. It's pretty gross. Gosh, I want to assess one this hard. I want to see if you can do one this hard, but grading one this hard is really gross.
Just give us completion.
No. I will die with the pen in my hand before I do that.
Congratulations.
All right. Now, first thing is you don't want to do all this log stuff if it's not necessary. So mentally, this part doesn't have to be shown. It's only the L'Hopital that has to be justified. But in my mind, I'm saying this approaches infinity to the 0. Is that an indeterminate form? It is. Okay, so we should proceed and do all the work. So we go E. Limit as x goes to pi over 2 from below of pi minus 2x log of tangent of x. Okay, it's a pretty rare mistake at this point that people are making, that taking the derivatives now. You absolutely 100% cannot take the derivatives. It has to be a quotient. It has to be, period. Okay, so if you're one of those people that's still taking the derivative here, stop that. Okay? E to the limit as x goes to pi over 2. I can't think of many cases where I ever put the log statement in the denominator. It almost always stays. Okay? Now, this is where it's a quotient, and this, therefore, is where you justify L'Hopital. So if I were to say the limit as x goes to pi over 2 from the left of log of tangent, tangent goes to infinity, and the log of infinity goes to infinity. Pi minus 2x to the negative first. Pi minus 2x goes to 0, and 1 over 0 goes to infinity. And so is this a L'Hopital case?
Yes.
It is a L'Hopital applicable case. We proceed with the derivative, either below or next to, whatever you want. Okay? I'm just going to keep looking down. So, by L'Hopital's rule, the numerator derivative is tangent in the denominator, 1 over tangent, and secant squared, if I'm not mistaken, right? The denominator derivative is negative 1, pi minus 2x to the negative 2 times negative 2 via chain rule, right? All right. Let's clean that up a little and see where we're at. E to the limit as x goes to pi over 2 from below. So the trig, I think I'm going to go cosine squared, and the tangent I'm going to call sine over cosine. So that's cosine over sine, if I'm not mistaken. And this stuff is a positive 2 over pi minus 2x squared? Are you with me? Do you agree with that? Okay. I'm going to clean up a little more. So I'm getting 1 over cosine sine, and pi minus 2x would get flipped up and put in the numerator over 2. Check. Okay. So this is where I thought of a little better way to go here. In terms of where I'm at, I can't clean it up anymore, and I still have 0 over 0, right? Right? Do you agree? Okay. So it's L'Hopital again. You could do the product rule down here, but I thought, let's call 2 cosine sine sine of 2x. Are you cool with that? Okay, because then at least we don't have to do the product rule on the second part through. So, by justifying L'Hopital, the limit as x goes to pi over 2 of pi minus 2x squared is 0. The limit as x goes to pi over 2 from below of sine of 2x is 0. So by L'Hopital, one more time, I promise this will be the last time, will be 2 times pi minus 2x to the first times negative 2 over 2 cosine of 2x. And so that becomes e to the, right? Oh, sorry. So what does the numerator go to? Negative 4, but times very small. So approaching 0 over cosine of pi. 2 cosine of pi is negative 2, but it doesn't matter because this is. Hey. So, now, if you did all that work, I am going to protect the integrity of your work because you'll be outraged to know that there are some people in this class that every time they do one of these, they just say, oh, it's 1 to the infinity or it's just 1, and they call it good. Well, you can bet I'm taking off on those stuff. Okay? That's ridiculous. I demand that you get satisfaction for doing all that work, and you get to keep your point with those people I now hate. Right? I don't really hate them, by the way. 220 check. That was exhausting. Number 3. Question on 3.
Yeah.
Boom. Yeah. So I imagine the physics people had a little bit of an advantage. Well, you're all physics people, I guess, at this school. But
That one wasn't too hard.
this ball is thrown at an angle of 20 degrees with a horizontal and a velocity of 100 feet per second in this direction. Okay? Now, if you look at the horizontal and vertical components, there's a horizontal velocity, I'll call it v sub x, and a vertical velocity v sub y. And yes, the vertical velocity is definitely dependent on gravity, but the horizontal is not. Just think basic trig. I could use a cosine. Yeah. So v sub x, or the horizontal component, is 100 cosine 20. I don't know what he's doing throwing degrees in there, but it is what it is. So put your calculator in degree mode or use the physics part of whatever you use a page. And that's the horizontal component, yay? Second part of the question is, what's the horizontal displacement during its first 3 seconds of flight? The horizontal component doesn't change because of gravity. So it's this for all time until it hits the ground, of course, and then it all stops. But the horizontal displacement is a function of both the velocity and change in time. So it's 100 cosine 20 feet per second for 3 seconds, and that is whatever it is.
That was way simpler than I thought it was.
Yeah, you might have overthought that one. It wouldn't be the first time you did that. All right, 34. 34, never mind, that's done. 24. Question on 24. Is 24 still a question, somebody?
It's also just on the.
It is?
No, never mind.
Oh.
We'll talk about that.
Oh, okay. 24, no?
Yeah.
Yes? Okay. It got a little gross on me, so I started to doubt myself, but I did check some calculators that worked out. So me, I started going this way. Natural log looks like this, and normally crosses at 1. So absolute value of natural log would go like this still there, but up here. So at 1/2, we're looking at this kind of graph. Absolute value then, as typically happens, is piecewise. The natural log absolute value is the same as the function of normal natural log for x beyond 1. But this is actually going to take the opposite of the y value. So this is the opposite of log for x between. Are you with me? All right, now so we're integrating the area under the curve. We would have to do an integral from 1/2 to 1 for negative natural log of x, and then another one from 1 to 2 for normal. Are we cool? So then, last gotcha is, what is the antiderivative of log of x? Yeah, x natural log of x, it's x natural log of x minus x with the negative then, the signs will change. And x natural log of x minus x, it comes from ultraviolet voodoo, so it's negative just like ultraviolet voodoo is. 1 to 2. Just be careful plugging in and you should be on your way. Okay?
What is it?
Because I know I screwed up on my
So I got negative 1/2 plus 1/2 log of 1/2 plus 2 log of 2.
Ooh, that's what I got.
I got negative 3/2.
Hurrah, hurrah.
Your non-log terms had it. Okay, good job. I'll raise it up here in
I
case.
take a lot of pride in getting my grades as council. So that's
It's 2 log 2.
yeah, I know I did.
All right. Boom. We're good. Yay. Stop recording.